Metric system review, conversions, method, and examples. There are many different ways to convert from one metric prefix to another. Two major methods includes the dimensional analysis, which is a great way to learn the system, and moving the decimal place, sometimes called by biology teachers the king handy-dandy technique. I really don't care which method you use, and there are many others besides these two. What I do care about is that whatever method you use, you must be fluent in it. What do I mean by fluency? That is, you need to be able to translate between prefixes quickly, automatically, and correctly during labs, problem solving, and tests. The cognitive load, what you have to think about in this class, is going to be reasonably high. You need to have the units be automatic so you can free up your thinking for other things. What are the initial conditions? What are the final conditions? What information is not explicitly stated in the problems? What forces are present? Is there acceleration present? Do I have to worry about any angles? And what angles do I worry about? So there's going to be a lot to think about as we get farther along in physics and the problems become more complex. So what we want to do is make sure that the units are not something you have to spend time with. They should be simple and automatic. Going from centimeters to meters should be an easy thing. To keep this simple and automatic, my preferred technique is moving the decimal place. And to be honest, I've done so many metric conversions, I don't even think about it anymore, and I don't have to write out anything. I can just automatically go from one to the other because I understand what the powers of 10 are and what they represent. But if you're not quite there yet, it really helps to know where everything fits in this nice scale of powers to 10. So going back to our prefixes, there are 6 ones that we normally use. Here we have 5 of them. Mega represents 10 to the 6. Kilo represents 10 to the 3rd. Remember, these go by powers of 3. If there is no prefix there, if it's only the unit itself, it's 10 to the 0. 0 means nothing, okay? Which means the same as multiplying by 1. Milli is, of course, 10 to the minus 3. Micro is 10 to the minus 6. And nano is 10 to the minus 9. So they go by powers of 3. 6, 3, 0, negative 3, negative 6, negative 9. Those are the 5 most common, and then that other one, the guy that sneaks in that doesn't follow this rule, is centi. Centi, it's right here, and it represents 10 to the minus 2. These dashes in between mega and kilo, in between all of them, represent powers of 10. This would be 10 to the 5th, this would be 10 to the 4th. Now, there are prefixes for 10 to the 5th and 10 to the 4th, and you can go and memorize them if you wish, but they're not used very often at all. In fact, scarcely ever in the scientific literature, so I don't really see any reason to force you to memorize those. What you do need to know is that there are places right there that you need to be aware of. Again, between kilo and no prefix, we have a 10 to the 2nd and a 10 to the 1st. Between the no prefix and centi, we have a 10 to the minus 1. Between milli and micro, we have 10 to the minus 4, 10 to the minus 5. Between micro and nano, 10 to the minus 7, 10 to the minus 8. This is quickly looking ugly, but in reality, it's fairly straightforward. If we wanted to go from, say, 311.08 kilometers to millimeters, okay, we're going from the K prefix to the milli prefix. K, 10 to the 3rd, milli is 10 to the minus 3. We're moving 6 places. Okay, which direction are we moving 6 places? Well, we're going from kilo to milli, so we're moving to the left. So I look at the powers of 10 and say, okay, it's going to be 6 places. You can also count them. So we've got K, 1, 2, 3, 4, 5, 6. So we're moving over 6 in that direction. So we rewrite this, 311.08, find our decimal, We go 1, 2, 3, 4, 5, 6. And we put the decimal right there. And to make up for those blank spots, we have to fill them in with zeros for placeholders. So 311.08 kilometers equals 311.080000 millimeters. So let's say we want to go the other direction. We want to go from 976.2 nanometers to just plain meters. Nano is 10 to the minus 9th. Plain meters is 10 to the 0. So we have a difference of 9 movements of the decimal place. Which direction do we go? Well, we're going from nano to no prefix, so we're going to the left. Again, if you want to, you can count that. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, we're going from the right to the left. So I'm going to rewrite that down here, 976.2. Here's my decimal place. I'm going to move it 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put my decimal place there and fill in those blank spaces with zeros. So we have 0.000000976.2 meters in 976.2 nanometers. Again, I would strongly recommend, to begin with, just writing that out someplace on your paper. It makes no difference where. I'm not going to look for it. Go ahead and try and convert 4.58 nanometers to millimeters. You give it a shot first, and then I'll go ahead and do it. From nano to milli, this is my nano, this is my milli. Nano is 10 to the minus 9th, milli is 10 to the minus 3rd. There's a difference of 6. I can also count that, and I'm also going to the left. But I can count it too. 1, 2, 3, 4, 5, 6. Note, when I'm counting that, I have to include those little placeholders. So I'm going to move 6 to the left. So 4.58. Here's my decimal point. 1, 2, 3, 4, 5, 6. And then I fill in those empty spots with zeros for placeholders. So 0.0000458 millimeters. Next, 12.02 centimeters equals how many meters? Okay, centi is the one that doesn't follow the rule, so it doesn't go by threes. It's 10 to the minus 2. It sits right next to milli, so I'm going to fill it in. I'm going to put in my centi right here, 10 to the minus 2. I'm going from 10 to the minus 2 to 10 to the 0. There's a difference of 2. I'm going to move the decimal to the left. So rewriting it, 12.02. I'm going to move it over 2 spots. 1, 2. So it's 0.1202 meters. Again, up here I could have done counting it like that, and that would have been fine also. Next one. 0.56 milliliters equals how many kiloliters? So go ahead and give that a shot. Alright, I'm going from milli to kilo. This is 10 to the minus 3. This is the 10 to the positive 3. There's a difference of 6 there. So it means I'm going to be moving 6. I'm going that direction. So I'm going to be moving it to the left. I can also count these. So from milli, 1, 2, 3, 4, 5, 6. Gives me the same piece of information. So 0.56. I'm going to move it 6 to the left. 1, 2, 3, 4, 5, 6. Right there. Fill in those spots with zeros. We write it so it's neat. 1, 2, 3, 4, 5, 6. 6 zeros. 0.0000056 kiloliters. There's 0.56 milliliters is equal to a small amount of kiloliters. Let's try one more. 3 kilometers to meters. Okay, well, kilometers is 10 to the third. Meters has no prefix, so that's 10 to the 0. So the difference of 3, I'm going in that direction, so it's going to be 3 to the right. Or I could count it starting at K. 1, 2, 3. Again, the same piece of information. 3 has no decimal in it. It's inferred. The decimal goes right here. I'm going to move it 3 places to the right. 1, 2, 3. So that would be 3,000 meters. So 3,000 meters. And that's the end of all my examples. Now you can go try and do some practice ones.